Okay, so for any sets A and B, we want to prove that A intersection B complement is equal to A complement union B complement. So let's go ahead and start the proof. So we have that X is an element of A intersection B complement. So by definition of complement, this means that X is not an element of A intersection B. So what X is not an element of A intersection B is, it's the same thing as it is not the case that X is in A and X is in B. So we write that because this is of the form not P and Q, right? This is of the form not P and Q. So we know not P and Q is logically equivalent to um, not P or not Q, aka X is not an element of A, or X is not an element of B, right? This is, well, I don't need that parenthesis. This is not P or not Q, right? P being X is an element of A, and Q being X is an element of B, right? So now we have that X is not in A or X is not in B. So this means that X must be an element of A complement, or X must be an element of B complement. And of course, this means that X is an element of A complement union B complement. So we have that X is an element of A intersection B complement gets us to X is an element of A complement union B complement. So for every X, let me put implies, for every X, X is an element of A intersection B complement if and only if X is an element of A complement union B complement. So if we have this, this means, this is the same thing as saying that A intersection B complement is equal to A complement union B complement. And that's what we set out to do. We set out to prove that A intersection B complement is in fact equal to A complement union B complement.